So, welcome back to IEEE CSOC TV, and here joining me at the end of the second day of ICCE 2016 in Las Vegas is Xiaoyu Sun, who just gave an interesting tutorial on materials being used in consumer electronics devices. Now, first of all, thanks for joining us. And my first question to you is, what common materials are used in consumer electronics devices such as tablets?
There are different materials can be used depending on the purpose. It can be structural, can be functional. So a lot of, for example, thermoplastics can be used, and depending on the requirements, you can also add in functionalities or other, fillers to make it stronger.
Okay. What kind of properties are important when choosing one material over another?
Well, again, it all depends on the end applications. For example, if you're designing antenna devices, you want to make sure your plastic does not have any water in there. Mm-hmm. And then, for example, if you wanted to design a display material, right? So you want it in a film kind of format. You want it to be transparent as possible, right?
Okay. Yeah. What about speed of reactivity to electrical signals, data communication, range, cost, and any other properties?
You mean the speed of the data transmission? Different materials can give you different kind of transmission speed. It all depends on, again, for example, if you're talking about optical signals, then you want the light transmission at the light optical range to be highest enough, especially at the IR range.
What are the biggest growth areas for new materials, in your opinion?
Again, we are looking at consumer electronic devices to develop in a disruptive way. So we would like to see more wearable devices, Internet of Things, and more to incorporate more functionality to it. Now, really depending on the form of if it's going to be a two-dimensional or three-dimensional materials, we're trying to get ready to design smart materials to make it, a solution for both ways. Yeah.
You explained in your tutorial that it can sometimes take a long time for a new material to be commercialized. Why is that?
Well, we're talking about maybe chemistry, or even because the actual processing requires a lot of efforts on, to be really precise. So that actually can be very high standards versus if you already have material you wanted to come up with a device for example, the things that most of the IEEE electrical engineers would do is that you have available materials. In our case, for chemistry to happen or for new forms to happen, it requires a lot of precision, a lot of efforts, and in the research and development areas. Yeah.
Let's talk for a moment about the future. Now, in your talk, you mentioned bendable materials that are perhaps conductive and perhaps even touch sensitive. Could you say a few words about these?
I think that's actually more about how people's perceptions, right? So let's say some people like hard glass, flat kind of screen. Some people would like something to roll together. Actually, as a matter of fact, I think some companies, I don't remember the name, but they already came up with rollable devices. Now, being a material supplier, we have to really be careful and be, accommodating all these trends. Yeah, so that's why, we try to come up with solution for both ways.
Good. Tell me about silver nanowires.
Silver nanowires, I mean, they are, like I said, they're for the flexible kind of solution, they can be more accommodating than maybe ITO for display, if that's what you meant. Yeah.
Okay, so they're bendable?
To some extent, yes.
Let's just finish with a short A to Z of materials for the layperson who perhaps doesn't have so much insight. Tell us about plastics and resins. What are the main differences one should be aware of?
Plastics and resins, they can be the same material or they can be different. Like the terminology itself, sometimes people use it in both ways. But in our case, we use resin when we indicate something like a more kind of neat resin or a base material, and we use plastic when it's in its final form and ready for sale. Yeah.
Good. And just going a bit deeper into resins, there's amorphous and crystalline. What are the main things we should know about those two different categories?
Well, I think I'm not going to give a lecture here on the polymer science, but the amorphous materials, usually they're transparent. So crystalline material, it depends, like the kind of material you're talking about. For example, some PET, they're crystalline, but they're transparent. But then other materials like nylon, they are semi-transparent, semi-crystalline, but they're not transparent.
Brilliant. Thank you very much again for the tutorial and for having a few words with us. And that concludes the second day of ICC 2016. Thank you.